Okay, this is the next three questions of this analytical exam question, and here we go. It says determine the size of angle PQR. Well, we've got two lines, we have two gradients, and well, we can figure out the gradients pretty easy. We've got two gradients we can figure out pretty easy with these lines. And the thing is, we get angles by going shift tan of the gradient because tangents are, the tangent of an angle is a gradient. So all we have to do is go shift tan. Our calculator will tell us the angle that fits with the line. Well, let's take a look at maybe even this line right here. Let's call it alpha, this first line, QR. Well, first, let's find the gradient, 4 minus 1 over minus 1 minus 0. If we do that, we get -3. And then all we do is go shift tan of -3, and we'll get a negative answer. We have to add 180, and then we'll get this bigger angle of 108,3 degrees. Now, that's a mark. Just shift tan of the gradient. You get a mark. Even if you don't have this picture figured out like this, I extended the lines and made a horizontal. It helps me to think about it anyways. Well, now there's this big angle beta. I need the gradient of this line, PQ. I could go 4 minus 2 over minus 1 minus 3 and get the gradient, or I could put this in the form of y equals, and then it would turn into, whoa, I'm going the wrong way here. It would turn into, let's see what it would turn into. It would turn into -1/2. You see, you just subtract x, divide by 2. The gradient is -1/2. Now shift tan of -1/2 and add 180. You'll get a negative angle, then you add 180, you get 153.43. So there's your big angle beta, your smaller angle alpha, the one that fits with PQ and the one that fits with QR is alpha. Well, now I'm looking at these two angles. If I took beta and I took away alpha, I'd be left with the opposite angle where PQR is. And that's exactly what you do. You just subtract those angles, 153.43 minus 108.43. You get that 45-degree angle there. And by vertically opposite angles, PQR must be 45 degrees. And that's your answer. The next question says, SP and T are collinear. So there's SP and there's a T somewhere up here, and they're in the same line. Well, if they're in the same line, it means they have to have the same gradient. So the gradient from T to S has to be a third. So you just do that. Make the gradient from T to S, K minus 1 over 7 minus 0. Make it 1/3, and then solve that equation. And that's all we do. 3 times K minus 1, 7 times 1 on the top. Add 3, you get 10, and then divide by 3, you get K equals 10 over 3. So the key thing is, look, if they're collinear, they must have the same gradient, and then just make the gradient formula go K minus 1 over 7 minus 0 equals this 1/3. Cross multiply, add the 3, divide by 3, and you get your answer for K. The last question is really an easy one if you know what to do. First it says PQR. The only place I could be is down here for V. Well, how am I going to make sure that it's a parallelogram? It's only 2 marks, though, 2 for each coordinate. How could I find it easily? And this is what you do. You just look at Q and go, hey, from going from here, from -1 to 3, I went 4 to the right. Going from 4 to 2, I went 2 down. Well, just do the same thing to R. Go 4 to the right and 2 down. Add 4 to 1, you get 5. Subtract 2 from -2, go 2 down, you get -4. And that's it. The coordinates of V are 5 and -4. Just whatever happens to Q, figure out what happened to go from Q to P, do the same thing with R, and you're going to get the answer. And that's it. Okay.